this is my reaction to a powerful intellectual discussion titled "Did We Get Evolution Completely Wrong?" by Richard Dawkins vs. Dennis Noble, taken from the channel The Institute of Art and Ideas. All credit to them for the original content. What I am here to do is not an attack, but a humble opinion and a reflection to the conversation through the lens of faith, scriptures, and purpose. Therefore, as you watch, do not forget, only means you can use to help support and encourage me on this particular goal is to share my content. Please like, and also feel free to comment your own particular opinions. I will be glad to join you at the comment section too, to share more views with you. Do not forget, if you have not yet hit the subscribe button, do that. Let's go right there.
I think what organisms are doing is partly through their social choices, choosing which genes they will allow to survive. That's what organisms do. Social selection, yes.
How? I mean,
well, who you mate with, for example. Why do we marry anybody? Isn't that why we do it?
This is perfectly Darwinian, what you're talking about.
Yes, absolutely, I agree. And Darwin was a Lamarckian. I think what we need to do here is to get another element into this, because I think what you're really worried about is how can it be that the body can actually change the genome? And that's the big question. Now, the reason we know that it can is that we know it controls it. That's the first step. So let's see first of all how that can be done. I've two very important colleagues who have done the work I'm going to describe, so I'm going to credit them. Dick Chen worked with me as a graduate student way back in the 1960s and is now working at the University of New York and has done part of the experiments I'm going to describe, and Anand Parekh, who is a physiologist in the same department as me in Oxford. And what they've done is absolutely beautiful. They've asked the question, you see, it's the relevant question that I think Richard is asking. How can it be that the surface of the body or of a cell, it might be that it's a unicellular organism, then it would be the surface of the organism. How can it know, how can its nucleus know that there is a need to change? And we now know how that can be done. What they've shown is best described by imagining, first of all, that a single nucleotide is about the size of my fist. And it's situated in the nucleus. So let's put that in the center of the cell. If we did that, on that scale, the surface membrane of that cell would be way up in Scotland. How on earth can it be that a signal through a receptor on the surface can influence the nucleus? And we now know how that can be done. What they both found, doing different experiments in different cells, was that calcium coming through protein channels in that surface membrane, using the same metaphor, way up there in Scotland, creates a calcium concentration in a small subspace underneath the membrane, and that high calcium triggers a chemical reaction that produces a messenger. And that messenger gets attached to some extremely important proteins in the cell. Those proteins are called tubulins, and the name suggests what they do. They form tubes. Literally, there are tube trains in cells. And I'm not joking, because what happens is those tubulins run all the way through from one edge of the cell to another. They have little motors on them, little molecular motors, and they can attach a messenger molecule to the motor. And what then happens is phenomenal. They literally walk along the tubulin. It takes just a few seconds to go from that surface, imagine on this scale, way up there in Scotland, to the nucleus. What does it do? In those experiments, it changes the gene expression levels in the relevant genes that matter for that particular function. Now, the only thing that's missing here, and I'm sure Richard will pick this up very quickly, so I'll say it myself, is that those are very recent experiments done 2016 and more recently 2018, I think it was. Anyway, the important point is that we don't yet know how that induces genome change, and I really mean actual change in DNA. And yet we know also that those processes must be able to do that, because we can show that. Let's take a tumor developing your body, and it's a bad situation. You're beginning to get metastasis. So the doctors get out the radiotherapy and the chemotherapy, they attack it and try to destroy it. What happens? The tumor cells themselves tell the genome to increase the mutation rate. How can they do that? Precisely by the kinds of mechanisms I've just described. Because the mutation